This video is for March 8th. We're looking at the asymptotes of vertical, horizontal, and or slant of, of a function, rational function. This will probably be one of 2 or 3 videos that we go over. Here, we just want to get the vertical asymptotes. So what we can do here and determine the domain. So we were trying to figure out the domain and vertical asymptotes. So here we can factor our quadratics in this function. Our numerator would factor as x minus 6 times x plus 4 over x minus 11 times x minus 6. And from here we can say that x cannot equal 11, x cannot equal 6. Because if it does, then we would have 0 in our denominator, and that's not okay. So that's why x cannot equal 11, x cannot equal 6. Now from here, we notice that the x minus 6's, those cancel. And so we will be left with x plus 4 over x minus 11. So what's happening here? Well, the 6's cancel away. If anything cancels out, you have a hole. So what we say is f of x has a hole at x equals 6. So the function looks like it'll be continuous there, but what's happening is because it canceled out, we actually have a hole at that value. So with a value where x equals 6, it has a hole. Now, because the x minus 11 did not cancel, this stayed. The x cannot equal 11 stayed. And so what we say is f of x has a vertical asymptote. Vertical asymptote at x equals 11. Excuse me. So if it cancels, if the things cancel, the function ends up having a hole at that value. If it stays, then the function will have a vertical asymptote here. If you try this one, I recommend trying this one on your own. You're going to have a hole at x equals -7. And you will have, oh, sorry, that's false. X equals 3, and then you're going to have a vertical asymptote at x equals -7. But try that one out, see if you can get that. I'm going to go ahead and move on. Essentially what we talked about in class is our vertical asymptotes and holes, those always come from the denominators of our functions. So that's always going to come from the bottom of our function here. Never from the top, only from the bottom. And so that here, if it cancels out, we end up with a hole. If it doesn't, vertical asymptote. Go ahead and flip to the back side. I'm going to skip this piece, and this should say slant. Now we get to where the horizontal and slant asymptotes come from. And we can break it up into 3 cases. I'm just going to go straight to the cases. We talked about this briefly, not very long. It wasn't a very productive conversation. So I'm just going to go case 1. Case 1, I highly recommend taking detailed notes on this because this is something that you'll be able to use on your take-home assessment. It's also something that isn't necessarily intuitive. It's something that you're just going to have to know. I don't like that, but this is something that we can't explain fully without calculus. And in every time the degree, so in case 1, the degree of the denominator is bigger than the degree of the numerator. So if you look at our rational function over there, in our denominator, we have a degree of 2. I'm just going to write DEG equals 2. In our numerator, there aren't any x's, so our degree is 0. So because the degree in the denominator is bigger than the numerator, Every time that's the case, even if it was x to the 99th over x to the 100th, if the degree in the denominator is bigger than that of the numerator, then what's happening is this function has a horizontal asymptote at y equals 0 every time. Every time the degree is bigger in the denominator, we're going to have a horizontal asymptote at y equals 0. Every time. Now, we can also know something else about this function. Here, we can rewrite our function as f of x equals 2 over x minus 1, x minus 1, if we factor that quadratic. And ultimately, we can say, since those are both 1, x cannot equal 1. Will we have holes here? No, because neither x minus 1 canceled. Will we have an asymptote? Absolutely. So the what's in black will always stay for case 1. That's always the same. If the degree in the numerator or denominator is bigger than that of the numerator, we have a horizontal asymptote at y equals 0. This function also has a vertical asymptote. Asymptote at x equals 1. So we know that about this function. This is the key piece. This right here is the key piece that will definitely come up with other functions. All right. Let's go on to the second case. Case 2, the degree in the numerator is 2. Degree in the denominator is 2. So if degree in the numerator or degree in the denominator, those are equal, if degree in the denominator is the same as the degree in the numerator, is the same as then we still have a horizontal asymptote. Degree in the our function still has, or f of x has, a horizontal asymptote at, this one's a little different than the previous one. What we do here is you divide the leading coefficients. So I'm going to say at y equals a over b. A is leading coefficient. I'm just going to write coefficient in numerator. B is leading coefficient in denominator. So for example here, our degrees are the same. Our degrees are both 2. This case always is true. This is always true. If the degrees are the same, we take the leading coefficients and divide them, and that tells us where the horizontal asymptote is. So here, this function has a horizontal asymptote at, take the leading coefficients. Leading coefficient here is 2, leading coefficient here is 1, so at y equals 2 over 1, or just y equals 2. That's where a horizontal asymptote would occur. This is the important thing to know. If the degrees are the same, then we divide our leading coefficients to figure out our horizontal asymptote. But this function still has vertical asymptotes. We can factor this function. Our numerator, we cannot factor 2x. It's already factored. Our denominator we could factor as x plus 1, x minus 1. So from here, we know x cannot equal 1, x cannot equal negative 1, nothing canceled. And so here we have vertical asymptotes. This function in particular has vertical asymptotes at x equals 1 and x equals negative 1 as well. So this covers two of our cases, one where the degree in the denominator was bigger than that of the numerator. Then we have a horizontal asymptote of y equals 0. If they're the same, we have a horizontal asymptote by dividing our leading coefficients. Now we're going to see what happens if the degree in the numerator is bigger than that of the denominator.